What causes horizontal asymptotes? We're going to look at both vertical and horizontal, but we're going to start here by looking at the horizontal asymptote. And the horizontal asymptotes occur at the end behavior. The end behavior has to do with the x's. The x's are going out to positive and negative infinity. So if we look at this graph here, what we're looking at as x goes to infinity, what is y going to? Question mark. That's what the end behavior is. As x, we don't write it backwards like this, but as x goes back to negative infinity, the question is, what is y going to? And when we look at this graph, we're seeing as x goes bigger and bigger and bigger. Here's an x, here's the y. Here's an x, here's the y. Here's an x, here's the y. Here's an x, here's the y number. The y numbers are headed towards whatever that tail is headed towards. And it seems to be similar on the other side here. And I want to introduce something here. This is what we call an asymptote, horizontal asymptote. And it happens to be the equation y equals 1, because it's right in here between 2 and 0. And that's what we call horizontal asymptote. Now, if we look at x going to negative infinity, so x is going, to 4, y is here. X is 4.5, y is here. X is negative 5, y is here. And these y's seem to be approaching the same number that this tail is approaching. So in both cases, y is approaching 1. And over here, the y's are approaching 1. That's called the horizontal asymptote. Okay, then if we look over here at this other example, this one's a little bit more complicated. We have 3 branches here, but it seems to be exhibiting something on the end behavior. Here's a tail way out here at this end. Here's another table way out here at this end. And we're going to try to figure out, well, what are those tails doing? Well, in both cases, they seem to be converging right along the x-axis. And that's something we'll call the horizontal asymptote. And in this case, it's the y equals 0. Now, in both cases, y equals 0 and y equals 1. These are equations of lines. They're equations of horizontal lines. They're not part of the graph. The black is the real graph of the function, but the red lines are indicating some special phenomena happening in the graph. And that's the phenomena we're talking about describing here. So, in this situation over here, where x is going to infinity, we're wondering, what is y going to? Question mark. Well, y is settling down right here on this value. So it turns out y is settling down on the number 0. Now, we don't write these backwards like this, but I'm just showing it in the direction we're going. X is going backwards to negative infinity. Where's y going to? Well, this time, when x is like negative 2, y is right here. When x is, oh, that was 1.5, I think. Negative 2, y is right here. Negative 2.5 right here. Negative 3 or 4, whatever that number. Y keeps moving up and up and up, but it's not going up high. It's converging on 0. So in both cases, y is headed to 0. That's what we mean by the horizontal asymptote. Now, intuitively, what causes this behavior? It has to do with the function, of course, but it has to do with something we call the leading terms. Now, when x is going to a big number, let's call it 1 billion. I'm going to plug 1 billion in here for x. So I've got a big number plus 3 and a big number plus 2. So if you have 1 billion plus 3, the plus 3 does nothing to the billion. It's like a drop in the bucket. So when I have 1 billion there, adding 3 doesn't really do anything. I'm just going to take it out because it has no effect. On the bottom, if we have 1 billion plus 2 has no impact on the billion number. It's like a drop in the ocean. And if I I can remove it without really effectively changing the outcome. So when we plug in a big number here, it's going to equal basically the big number divided by itself, which anything divided by itself is 1. And that's what we're seeing with these infinities. The y's come out to 1. In a similar way, I'm going to erase this one and look at the other side. So when I have a big number for x, plugging it in here, which means I got to plug it in here and here and here. So I have to write this going this way to make space here, but it's basically 3 times a big number plus 1 over the big number squared plus the big number again minus 2. Now in the same conversation, if the big number is 1 billion, 1 billion plus 1 really is doing nothing. So I'm going to erase the effect of 1 because 1 to 1 billion doesn't change the billion really. Minus 2 on the bottom. 1 billion squared minus 2. The minus 2 has no effect on 1 billion squared, so it's basically no impact. It's like a drop in the ocean. Now 1 billion has, I think, 9 zeros. It's 1 with 9 zeros. And 1 billion squared has 1 with 18 zeros. So 1 with 18 zeros plus 1 billion. 1 billion is significant, but it's not going to really make a big impact by adding that to 1 billion squared. So yes, it's big, but not big enough to really affect 1 billion squared. So I can actually take this out because it's not really influencing the final outcome of this division problem. What we're boiled down to is all the calculation really when x is giant, when x is a trillion, a quadrillion, infinity, that it's these leading terms that influence the outcome. Now, these leading terms, we could see it like 3x over x squared. Hey, wait, the x's cancel. So I can cancel out that x and that x. And I'm going to have 3 over x. Well, so I could think of it this way. I can cancel this big number with one of those big numbers. And I'm going to have 3 divided by a big number. Now, what is 3 divided by a big number? Well, when you divide, the bigger the number is on the bottom, the smaller is the answer. It's going to be very, very small. And if we make this bigger and bigger and bigger, this is going to get smaller and smaller and smaller. So eventually, I don't have much room here. I'm sorry that I'm doing this, but it's all I got for technology right now. So eventually, this is going to go to 3 over a big number is going to go down to 0. The bigger I divide by something, the smaller my answer is. And that's what we're seeing here, that y equals 0. And we're seeing it in the asymptote. So intuitively, this is what we're exploring here on horizontal asymptotes.